Have you ever wondered if there's more to reality than what meets the eye? For most of us, reality is what we can touch, see, hear, smell, and taste. It's our everyday experiences, the tangible world we interact with. But what if I told you that there's an entirely different layer to reality, one that challenges our classical understanding? This is where quantum mechanics comes into play. Quantum mechanics is a fascinating branch of physics that deals with phenomena on a remarkably small scale. We're talking about molecules, atoms, even subatomic particles. It's a realm where our traditional laws of physics seem to take a back seat, making way for a world that's incredibly strange, yet undeniably real. This strange world has sparked numerous philosophical debates about the nature of science and reality itself. So prepare to have your mind expanded as we delve into the fascinating world of quantum mechanics and its philosophical implications. To understand the philosophical implications, first, we must grasp the basics of quantum mechanics. Quantum mechanics, at its core, is the study of the very small, the world of particles that are so tiny they're beyond our normal perception. However, these minuscule particles behave in ways that are quite contrary to our everyday experiences. Let's start with the concept of wave-particle duality. It's a principle which proposes that all particles of matter exhibit both wave-like and particle-like properties. It's like being at two places at once. Imagine you're both at home watching a movie and also at the grocery store picking up milk. Sounds impossible, right? But in the quantum world, this is the norm. Then we have superposition, a principle that's even more mind-boggling. It suggests that a quantum particle exists in multiple states at once until it's observed or measured. Think of it like flipping a coin. While it's in the air, it's both heads and tails simultaneously. But when it lands, it assumes one definite state. The act of observation, according to quantum mechanics, determines the outcome. Finally, there's quantum entanglement, one of the most intriguing principles. It's a phenomenon where particles become interconnected, so that the state of one instantly affects the state of the other, no matter how far apart they are. Imagine you have two dice, and no matter how you throw them, they always show the same number. This connection that transcends space is what Einstein famously called spooky action at a distance. These principles, while fascinating, challenge our understanding of reality and how we perceive the world. They suggest a universe far removed from our everyday experiences, a universe where particles can be in two places at once, where observation determines outcome, and where distant particles can be mysteriously connected. This is the quantum world, a world that is strange, fascinating, and continues to perplex scientists and philosophers alike. It's a world that invites us to question our understanding of reality itself. Now that we have a basic understanding of quantum mechanics, let's explore how it changes our perception of reality. Quantum mechanics throws a wrench into our traditional understanding of reality. You see, classical physics, the kind Sir Isaac Newton formulated, views the world as concrete, predictable, and deterministic. But quantum mechanics, on the other hand, introduces a world that's anything but. One principle that illustrates this is the concept of superposition, a term you probably know from the famous thought experiment, Schrödinger's cat. Superposition suggests that a quantum system can exist in multiple states simultaneously, each with its own probability. This isn't a mere abstraction, it's a fundamental aspect of the quantum world, one that defies our classical intuition. Here's an example. Imagine a quantum particle that can be in two places at once. It's not that it's moving so fast we can't see it, but rather it exists in both locations simultaneously. It's in a superposition of states. Now here's the kicker. This particle remains in superposition until it's observed or measured. At that point, the particle appears in one place or the other, not both. This leads us to the idea of multiple realities. According to the many worlds interpretation of quantum mechanics, when we observe the particle, we're not causing it to be in one place or another. Instead, our universe splits into two, one where the particle is in the first location and the other where it's in the second. So in essence, quantum mechanics suggests that multiple realities can exist simultaneously until observed. Each observation might be creating a new branch of reality, a new world, if you will. It's a mind-bending concept, isn't it? But hold on, there's more. Quantum mechanics doesn't just change our understanding of reality, it also has significant philosophical implications. Let's delve into the philosophical heart of quantum mechanics, beginning with determinism and free will. Classical physics, with its predictable, law-governed universe, is deterministic. You could, in theory, predict the future if you knew the position and velocity of every particle. Quantum mechanics, however, with its inherent uncertainty, challenges this idea. The Heisenberg uncertainty principle states that we cannot simultaneously know both the position and velocity of a particle with absolute precision. This injects an element of randomness into the universe, a feature that has sparked heated debates about free will and determinism. Next, we consider the nature of reality. Quantum mechanics suggests that particles can exist in multiple states at once, a concept known as superposition. It's only when we observe these particles that they collapse into a definite state. This challenges our classical understanding of reality as something concrete and objective. Instead, it proposes a reality that is probabilistic and subjective, dependent on the act of observation. Which brings us to the role of the observer. In the quantum world, the act of observing seems to change the outcome. This is puzzling because it suggests that consciousness, or the act of observation, plays a fundamental role in creating reality. This is a radical departure from the classical view where observers are merely passive spectators. The philosophical implications of quantum mechanics are profound. They challenge our deepest intuitions about the world and our place in it. They suggest a reality that is far more mysterious and complex than we could have ever imagined. They invite us to consider the possibility that the universe is not just a grand machine governed by laws, but a deeply interconnected web of relationships, where observers actively participate in shaping their own reality. These implications have led to many debates and have left us questioning the nature of reality and our place in it. Quantum mechanics is a fascinating field that challenges our understanding of reality. This profound statement is not only a starting point, but also a summation of our exploration thus far. As we draw to a close on this intellectual journey, let's take a moment to reflect on the key points we've discussed and the intriguing questions we've wrestled with. We began by delving into the basics of quantum mechanics, an area of physics that deals with phenomena on a minuscule scale. It's a world where particles can exist in multiple places at once, where they can spin in two directions simultaneously, and where observing a system can fundamentally change it. Talk about a plot twist. This quantum realm, with its bizarre and counterintuitive rules, presents a stark contrast to the classical Newtonian physics that govern our macro world. The quantum world is not just a scaled-down version of the everyday world, but something more complex, more mysterious. It's a world where the impossible becomes possible and the improbable becomes inevitable. We then explored how quantum mechanics changes our perception of reality. The uncertainty principle, superposition, and quantum entanglement. These phenomena force us to rethink our conventional ideas of space, time, and causality. They challenge us to accept that at the quantum level, reality does not exist until it is measured, and that two particles can be entangled in such a way that the state of one instantly affects the other, no matter how far apart they are. These quantum quirks have profound philosophical implications. They compel us to question the nature of reality itself. Is reality really out there, independent of us, or is it somehow dependent on our observation? And if the latter, to what extent? Is reality deterministic, as Newtonian physics would have us believe, or is it inherently probabilistic, as quantum mechanics suggests? These questions lie at the intersection of physics and philosophy. They remind us that science is not just about collecting data and making predictions. It's also about interpreting those data and predictions, about making sense of the world. And sometimes, that requires us to think philosophically, to question our assumptions, to embrace uncertainty and paradox. Indeed, if there's one thing we can take away from quantum mechanics, it's that reality might be far more complex and fascinating than we could ever have imagined. It's a world where the strange is normal, where the impossible is possible, where the rules of the game are anything but straightforward. But that's what makes it so exciting, so intriguing, so endlessly fascinating. So, as we conclude this exploration, let's not see it as an end, but as a beginning. A starting point for further inquiry, for deeper understanding, for more philosophical pondering. Because the quantum world is not just a world of particles and waves, of superpositions and entanglements, it's also a world of ideas, of questions, of possibilities. Thank you for joining this journey into the quantum world.